How to calculate the resistance of an LED diode? Well. There are many videos and a lot of information on how to do it. I'm not going to reveal any secret. If we put 5 volts in it, we should put approximately 100 ohms. If we put up to 10 volts, then with a 300 ohm resistor it will work very well. And if it's 12 volts or 13 volts with a 500 ohm resistor, it will work fine. That's no secret, but I'm going to explain how I do it, because I may want to give them an exact brightness, and I need to calculate the exact resistance. It's not the same thing for an LED diode connected to a television standby that simply has to give a little light to indicate, than on a panel where it has to illuminate more. Well, before starting the video I have to clarify that an LED diode is not a resistor, it's a semiconductor. It's a junction where photons are produced, so it needs a threshold voltage to work. It is not like a resistor that you put more or less voltage on and a more or less proportional current flows. There has to be a minimum voltage in the LED diode for electric current to flow and produce photons. An LED diode starts at approximately 1.5 volts, well, a little more than 1.5 volts. Now what we are going to do is calculate the resistance. We will look at the intensity. We connect 1.5 volts and start to increase. We have to look at the current, that is, at the amps. We see that it already lights up because it is close to a milliamp. We take 1 milliamp as a value. With 1 milliamp it already lights up. We can use it as an indicator light. We can increase it further, always looking at the current, which is what can damage the LED if we exceed 20 milliamps. The voltage drop is what the LED itself has to take. Now we are only testing up to 20 milliamps. If we increase it, it lights up more. For example, we want a brightness of 5 milliamps, because it is an amount that the LED is for what we want. Well, we write down the values that it has given us. 1.88 volts is what we have set and a current of 0.005 is circulating, which is 5 milliamps. This value divided, this gives us an equivalent resistance that the LED diode is opposing right now of 376 ohms. What voltage are we going to put on the red LED diode? Well, we are going to put a source, which is what we are going to feed it with, and we will calculate the resistance that it has to have in series. We are going to put 12 volts. And 0.005 amps have to circulate. Well, the total resistance must be 2400 ohms. If the LED diode is already 376, we will have to subtract that resistance from the total. So we have to put 24 ohms, that is, a 2K resistor, so that it continues to light up at the same intensity, because maybe what we want to put is next to a blue LED diode and the blue one does not work at the same voltage, but we can put the same intensity, which is 5 milliamps, so that they light up quite similarly. So now we are going to calculate the blue LED diode. We are going to lower the voltage to 1.5 so that we do not have any problems and we begin to go up. The LED must be connected correctly because it has polarity. We look at the current. We see that this needs much more voltage. We see that it is already starting to light up because it is close to 1 milliamp. I am satisfied with 1 milliamp for certain cases. We are going to put it at 5 milliamps. Here 2.87 volts fall and 5 milliamps circulate. The equivalent resistance that is opposing the current is 574 ohms in the blue LED diode. If we put 12 volts and 5 milliamps, it would be 2400 minus the LED. I will need a resistance of 1800 ohms, that is, the red LED diode would need 2K and the blue LED would need 1.8K for the same voltage and current. This is the way I do it because I am meticulous. There are videos that calculate the resistance and they are excellent videos, but I do it this way and I wanted to explain how I do it. Now we are going to calculate a green LED diode. Be careful that at 2.8 volts the LED diode will burn. We must take that into account. We must lower it to 1.5 volts, and from there we begin to increase so as not to burn them, that is, so as not to exceed the current. It starts to light up, it's close to 1 milliamp. There we have it. We want it at 5 milliamps, so we go up to 5 milliamps. Don't you get the feeling that the green LED diode makes less light with 5 milliamps than the red and blue? Let's put it at 6 milliamps, change the measurements. Okay, very well, the voltage is 1.96 volts and it circulates 0.006 amps. The resistance, which at this moment the LED is opposing with that voltage, is 326 ohms. If we put 12 volts, it would be a total resistance of 2000 ohms, subtracting what the LED diode keeps. We need a series resistance of 1600 ohms, 1.6K. Okay, and finally, I would like to try the white. Note that here with 1 milliamp the light it makes. There are high brightness LED diodes that can handle up to 30 milliamps. 5 milliamps gives off a lot of light. We go up to 15 milliamps to see how much light it gives off, and to 20 milliamps. Note that it is 3 volts that must be put in for 20 milliamps to circulate.